All right, so you've had a chance to go through these pedigree examples and use those checklists that we've just gone over in the notes to try and identify what kind of inheritance pattern is in each of these examples. Okay, so I'm going to walk you through the thought process that you should follow when you're doing these kinds of examples, and hopefully this will help you understand it a little better. So in this pedigree example number 1, okay, when I first look at this, the main thing I notice is I see a lot of squares colored in here, okay? Almost all of the squares on this pedigree are colored in, okay? So initially, I'm thinking Y-linked dominant because males are the only ones affected, okay? So this example is, in fact, Y-linked dominant, okay? Why? Only males are affected, okay? We do not see any affected females in this pedigree. The trait is passed on from an affected father to all of his sons. So, for example, here, individual number 1, okay, has 1 son, so it gets passed on to him. Here, number 2 in generation 2, he has 2 sons, and both of those sons have it, okay. Number 4 here in generation 1 has 2 sons, okay. 4 here in generation 2, he's got 3 sons, and all 3 of them have it, okay. The only unaffected males come from outside this main family. So number 7 over here, it's an unaffected male, but that's because this is a marriage to one of the people that are related here, okay. This one is unaffected because you have an unaffected father. Over here, you've got another unaffected person, okay, an unaffected male, because he's an outside marriage into this family. Okay, so that's why you see another one down there in generation 4 that is not affected. Okay, and if we take a look at this, all of the generations are affected. Okay, you've got affected males in generation 1, in 2, in 3, and in 4. It does not skip any generations at all. Now, example 2 can get a little bit difficult. Okay, so this one you may have skipped and come back to see what the other ones may have been, because each of these types of pedigrees would only be used once in these examples. Okay, so initially when I look at this, I see 4 males to 2 females that are affected. So I'm kind of leaning towards an X-linked to start, okay, because I see more males. Okay. But if we take a look at our list of things that qualify each of our different types of pedigrees, okay, autosomal dominant is going to fit this pedigree best. Okay, the reason for that is that we have the trait in both sexes. It's relatively equal in both sexes in this pedigree. Now, affected offspring must have an affected parent, okay? So number 9 here has an affected parent. Number 5 and 6, they have affected parents as well. Okay. When one parent is affected and heterozygous, and the other parent is unaffected, approximately 50% of the offspring will be unaffected, or will be affected. Okay. So if we take a look at this circle where number 3 is here, okay, we've got one parent that's affected, one that's unaffected. You've got half of their offspring are, half of their offspring aren't. Okay. And then the last thing that identifies this is unaffected parents do not transmit the traits. Okay. You've got 2 unaffected parents here. They all have unaffected children. There are no affected children from them, okay? So there's no way that they could be carriers, so there's no way it could be a recessive trait, okay? Now, some people might be led to think that this might be a recessive pedigree based on the fact that you've got it in these 2 generations, but you don't have it here, okay? That's not what recessive looks like, okay? If you've got it in 2 generations back to back like we have here, it's most likely going to be a dominant trait. Our third example, okay, this is a little bit clearer example of skipping generations, okay? So we've got one person affected in generation 1, we see none affected in 2, and then we see a couple people in generation 3 that are affected. Okay, so what I'm thinking first when I see this, I'm thinking it's got to be a recessive. Now, is it going to be autosomal or is it going to be sex-linked? Okay, so what you got to think about here then, okay, is take a look at who's affected. Okay, does it affect both sexes or is only one sex affected? Okay, if one sex is affected more, then that's going to lead you to believe it's a sex-linked trait. If both are affected, it's going to lead you to believe it's autosomal. So I've already decided I think it's recessive. And I see males are the ones that are affected. So that's leading me to believe that it's an X-linked recessive trait. So let's check on that. Is an X-linked recessive pedigree. Now the reasoning for that, okay, more males are affected than females, like I said at the beginning of this one. Affected sons are usually born to unaffected carrier mothers, which means it gives the appearance of the trait skipping generations. So we've got an affected father in generation 1, don't see anyone affected in generation 2, and then we've got 2 affected sons in generation 3. So individuals 2 and 5 in generation 2, they are most likely carriers of this trait. And that is how they were passed on to number 3 and number 6 in generation 3. We also never see this trait pass on from father to son. So remember I said this was going to be one of the characteristics that is going to be one of the most important to identifying X-linked recessive, okay? That's because we see from generation 1, none of the sons that he has there are affected. Okay, so that helps us to show support that this is X-linked recessive. And the last thing is all daughters of affected fathers are carriers. Okay, so the father here in generation 1 has 2 daughters, which is number 2 and number 5 in the second generation. Okay, they are both carriers, and we know that because both of them had affected sons. Okay, and we know from number 2 here, affected sons are usually born to unaffected carrier mothers. Okay, so to figure all these out, you kind of have to go through all of your checklists for each of the types in your notes and just see what things apply, and then whichever list has the most things that apply is going to most likely be the pedigree that you're working with. All right, next example, okay, I see more people affected here. I see it's affecting both females and males, and it looks like it's in every generation, so I'm thinking it's a dominant trait. But is it autosomal or is it sex-linked? Okay, so this one is an X-linked dominant because we see more females affected than males, okay? That is one of the leading things, but you got to check on your other things on your checklist just to make sure, okay? It doesn't skip generations, and the last thing on this list is probably the most important identifier for this one, okay? We see an affected father pass on the trait to all of his daughters, and that is one of the biggest characteristics that you're going to see with X-linked dominant pedigrees, okay? So if you see a father and he has all affected daughters, you should be thinking X-linked dominant. And then our last example, okay? Again, this one looks like we've got the trait in all of our generations, but I think we've used all of our dominant examples, okay? So our last one left is a recessive, so let's see if that fits, okay? Autosomal recessive is going to fit this the best, okay? Because we see the trait in both sexes with fairly equal frequency. Okay, we've got 1, 2, 3, 4 males and 1, 2, 3, 4, 5 females. That's pretty close to equal on both sides. The traits tend to skip generations. Now this one is super hard to see because you think that it's in every generation because you see an affected person in every generation. However, individuals 1 and 2 have, there's one person affected there. They have no affected offspring, okay? Number 5 in this pedigree over here, okay, this is not one of their offspring. They're married to one of their offspring, but it's not one of their offspring. So this trait has nothing to do with passing the trait in this family, okay? this trait did not come genetically from these parents. So individuals 1 and 2 here have no affected offspring. So it skipped the second generation here for them. Okay. And then the last thing to identify this is autosomal recessive, okay, is that affected offspring are usually born to unaffected parents. So if we take a look down here at individual 17, okay, their parents are 8 and 9. Individual 17 is affected, but 8 and 9 are not. Okay, the only way that we can have an affected person come from unaffected parents is with a recessive trait. Okay, so that is kind of the thought process that you need to follow when doing all of these pedigree practice problems. We're going to do more practice of this in the next week, okay? So we're going to be pros at this by the time that you are done. Okay, if you have questions on this or you'd like to go over this again, just let me know. Come to my office Zoom hours later today or ask me about them next week when we're back in person. Okay. If you've got other questions in the meantime, just email me, and I hope this helped you figure these out a little bit better.